Hello, this is Professor Han. Today I would like to demonstrate how to solve the resource allocation problem for Chapter 8. This video series may be broken down into several parts due to the size limit of YouTube videos. Let's start with this Gantt chart. See that? We have a list of 7 activities from A to G. And the second column is the resource requirement for each activity. And the third column here is the duration for the activity, for each activity, and early start time, and the deadline, and the slack time. And there's a time point from time 0, from time 1. So between time 0 and time 1, that's the first period. And just to make sure the concept. And the resource availability, it's 3. That means the company, this project only has 3 people available throughout the project life cycle. Okay. First, look at the basic rule. We look at early start time, 0, 2s, 6. So that's the scheduling window. 0, 2, and 6. We look at early start time. At time 0, since we only have one candidate activity, A, so this is a no-brainer. We just schedule A starting time 0. So we put the number of resource requirement for consecutive 2 durations. That's A. And I want to also add an order sequence here. Activity A apparently is the first to be scheduled. Okay, that's easy. But now next we are facing the challenge. Starting period 2, we're having 3 activities, B, C, D. Our job is to schedule 1 activity at a time. So among those 3 activities, which one is to be prioritized? Which should have the top priority? C, based on the rule, because it has the smallest slack time, which is 0 here. All right. So C, now resource. There's 2 programs for 4 periods. That's what we do. So apparently C is scheduled as number 2. After C is scheduled, so for period 2, for early start time of 2, we have 2 more activities to be considered. Either we have to either delay it if we don't have enough resources, or to load it. We have to make a decision. We cannot skip them. So for the remaining activities B and D, B should be prioritized because B has a smaller slack of 2 than the 6 associated with D. Okay, our next step to check, do we have enough resources to schedule B? Since B requires 2 programmers, apparently after C is scheduled, only 1 programmer is available. So we don't have resources for this 4 periods during which activity C is being scheduled. So our decision is this. We decide to delay activities B's early start time from 2 to 6. How many delays are making? 1, 2, 3, 4 crosses. That means we're delaying activity B by 4 periods. Okay, so the impact on its slack would be, currently has positive 2, but when we lose 4 days, that would be 2 minus 4. Your ending slack time in this case is negative 2. How do you interpret negative 2? That means for its original schedule of 12 periods, if we delay activity B by 4 periods, we would miss its deadline by 2 days. That means 2 days delay. So that's the interpretation of slack time. Now, when B is delayed, D is the remaining activity for period 2. Do we have enough resources to handle D? Since D requires one programmer, apparently we have no problem because the total is 3. So D is number 3. B is delayed from current period 2 to period 6. I will pause here. This is part 1. Thank you.